All right, I see that the door is shut, so we can start. And this presentation is called Build, Provision, and Deploy in the Cloud. It'll be about tools like Packer, Ansible, and Terraform. I have to be brutally honest with you, if you don't mind. And I'm a bit sick of the cloud, especially of the third, right? We're all techies in here, right? We're among friends. We can admit we're all developers, yes. Who doesn't consider him or herself a developer? Most of us, we're pretty sick of the cloud, right? That term, marketeers constantly using and abusing it. And I've done a lot of cloud presentations, and I do it for people who have zero experience in IT, like HR people. I did it in front of a room with 600 HR people explaining what the cloud was. And I started off with showing this slide and said, do you really want to know, and I built it up right, do you really want to know what the cloud is? Right? Okay. Well, I said the cloud is nothing more and nothing less than the internet. And I just walked off stage after like 20 seconds of speaking. And I waited there for about 30 seconds, and I came back on stage, and people laughed. And a lot of people are used to those terms like SaaS, PaaS, IaaS, private, public, hybrid, but as techies we know what all these things mean. But however, I still believe that there's value in the term cloud. It will disappear, of course. We use the term Web 2.0 on a daily basis, no one, right? But we used that back in the day. But cloud has an actual value. This is the intro, right? It's going to get technical in a minute. Cloud is just basically taking things away from plain sight from the user. We're abstracting things, and by abstracting it, we no longer make it the people's problem. We create flexibility, and the flexibility we have results in stability. That's like the elevator pitch of cloud, but I do believe in those concepts. Now, this is a picture I literally always show when I do cloud presentations. And it's my way to interact with the crowd, which I'm going to do. And as in regular comedy shows, you always hassle the people in the front row, and that's exactly what I'm going to do today. What do we see on this picture, dear people with SymfonyLive shirts on? What do we see on this picture? You can look there, that's close.
Some power cord and some vacuum cleaner.
Yeah. Most people say, yes, we're seeing a socket and a power cord, and that's what they're focusing on, because that's what's in focus on that picture. But the real thing that is happening is that someone is vacuum cleaning there. It represents core business. It's not the most fun task to do, but imagine you have people coming over for dinner, you want to make the house clean. You focus on getting that job done as quickly as possible, and the only thing you have is that machine, and the only thing you care about is all the way up here. What happens behind the socket is not your business. You don't necessarily know. I don't know in my house how that's connected to the fuse box and how that's connected to the outside world, and which power lines are used, and what kind of electrical plant that comes out. We don't know, and that's a bit how I see cloud. It's a utility these days. But I mentioned that the cloud is nothing more, nothing less than the internet, but it's the internet of today, not the internet of 1996, 1997. And we're going to approach it from a technical point of view, and the reason why we use all these tools in the cloud and why all these challenges have arisen is, first of all, developers have become more agile in their working, and that forced sysadmins to become more DevOpsy. That was the original idea. Things are moving so fast in such iterations. As developers, we do that, but as sysadmins and operations people, it's tough to keep up with all these changes, these constant deployments, this scale up, scale down. So we need ways to tackle this. And the DevOps group of sysadmins with developer experience formed a sort of a community and started figuring out these ideas. But luckily, virtualization happened for them, and Web 2.0 happened, where internet was no longer for the big corporations and the technical people, but the average Joe could go on the internet. They were always online, and they were online everywhere thanks to mobile. Like, that's a bit of a history lesson. But the tough things for us as people who are in IT are, of course, deployment. Deployment is where it gets tricky. That's where things start falling over, or when we scale out or scale in, right? Still agreeing? You feel these pain, these kinds? Yeah, I'm seeing very enthusiastic nods here. Yes, scalability and deployment are tough things, and when we're on cloud platform, servers can die on us every single second, and we have to be fine with that. So what do we need to do? We need to automate, and that's our task. But the problem with automation is that there's so many platforms out there, and by show of hands, who uses Amazon Web Services? Oof, a lot of people. Who uses Google Cloud Platform? A couple. Who uses Microsoft Azure? A couple. Who uses something else? What do you use? DigitalOcean, of course. I just wanted to put the big three on there, but there's many more. Anyone working with VMware? we work with VMware. I work at a hosting company. Anyone working with OpenStack? Yeah, I work a bit with OpenStack. I feel your pain. Yeah. So the tools I'm going to propose today are tools like Packer, Terraform, and Ansible. And they'll try to solve those automation problems, but also those multi-cloud problems, or the transition from one cloud to the other when you would need that. Do I need to, I'm seeing that you're taking, do I need to put that slide back there? Is that you trying to take a picture of? The goals here of this presentation is to have less lock-in, being able to automate across vendors, to do faster deployments, better scalability, better reproducibility. Like you can have an environment and you could duplicate that environment to have it in staging, in dev, in test. That's the goal. And the goal is also to have less human error at a lower cost. That's the mission. It's the mission of this talk. I'm not sure if I can convince you of that, but I'll provide you some ammo to do so. That being said, hi, welcome everyone. My name is Thijs. That's how I pronounce it. I'm a Dutch-speaking Belgian. Ich spreche auch ein bisschen Deutsch und danke für hier zu sein. Wir sind live aus Berlin, wie das Album von Rammstein, ja, live aus Berlin. Heute sind wir live aus Berlin. I pretty much, thank you, I pretty much ran out of German. The last time I properly learned German in school was in 1999. I had 4 hours of German per week and I was reasonably proficient because, aber ich übe nicht genug. Also spreche ich nur Niederländisch, Französisch und Englisch. So I'm Thijs Feryn on Twitter. This is sort of a social experiment I do every time, and the people who were at my workshop saw this as well. I put my handle on there, and that's the easiest way to get in touch with me. I stopped doing the business card thing, and every single event I speak, I see this slight spike, like a couple of followers, a couple of comments. So if you want to get in touch with me afterwards, give me good or bad feedback. Bad feedback's welcome as well. You can do it there. Professionally, I'm a technical evangelist at a Belgian web hosting company called Combel. We're Belgium, you might have never heard from us, but we're expanding. Our group is expanding, not in Germany, because Germany is too big of a territory. We're a bit afraid of entering those markets. That being said, I do a lot of public speaking. I'm involved with the PHP community. I even run PHP Benelux, a conference you might or might not have heard of. I'm the author of Getting Started with Varnish Cache, an O'Reilly book that was out this year, and that was also the topic of my workshop yesterday. Who attended my workshop? I don't know, you did. Yeah, remember you.
I won the book.
Yeah, you won the book, and you were a brave soul who did Docker on Windows, so that was a bit of an adventure. But we use Vagrant to solve these problems. And a bit of a fast forward, Vagrant is a HashiCorp tool, but Packer and Terramark are also HashiCorp tools. So I like the HashiCorp tools. So let's get into it. I have a Mac, so I don't have Visio on my Mac, so I do this in Keynote. So it doesn't look half as exciting as it should be, and it just doesn't have the right colors. But this is a way we could do it. This is the old school way. You create your server somewhere, and then you have your infra scripts that you commit to your Git repo, and your build server pushes them. It could be Ansible, could be Puppet, could be Chef, could be SaltStack, could be Bash, could be anything else. And then once that's done, you do the exact same thing. You push your application code to a repository, you send it to a build server, the build server does some continuous integration tasks, and eventually sends it to the servers. That's the goal. What I'm going to try to do today is see everything as code. So the repository that contains our application code is the same repository that contains maybe our Ansible scripts, our Packer scripts, our Terraform orchestration scripts. It's all together. And the build server bakes an image. We're going to bake a virtual image today. And that image contains our full stack, it will contain our application code, and it will be that one thing we could throw around and boot up all over the place. So we push it to a VM image and our cloud register just boot up servers. And booted up server contains everything, and that's what we're going to do today. So basically the application code plus the stack. And the stack is a generic term I use to make Apache or Nginx, PHP, MySQL, all those sorts of things. But keep in mind this is I'm going to keep it pretty generic. You probably use a different stack than I do, but 9 times out of 10 or 90% of your chances you'll have your stack or the tools you use is perfectly compatible with the tools I use. So let's start off with tool number 1, and that's Packer. Packer is a building tool. Who has heard of Packer? Okay, keep those hands up. Who uses Packer in production? That was a tricky question. In production? Well, we have projects, so our holding group has several companies, and one of the companies does AWS automation, and they use Packer quite a bit. So with Packer, you just give it a JSON file where you do some descriptions based on providers, and you choose your cloud platform, and it boots up a server and runs some scripts on it, and takes a snapshot, takes an image, and then reports back with the ID of that image, and that ID is then your Packer build. But how do we install our stack once we've booted up the server to take that snapshot off? I'm a big fan of Ansible. Who uses Ansible in here? This pillar in here blocks my view, so I'm going to have to walk this way to see all of you. Hi, welcome. Good to see you. So a lot of people use Ansible. Who uses Chef? Left, right, no one. Puppet? Must be some Puppet user. Salt Stack? Good old Bash? Yeah, still a couple. Well, Ansible I like, because it's quite simple. And what we do here is, eventually, we're going to take that VM image that contains our application codes, that contains our stack that was instrumented via Ansible, we build it via Packer, and then our infrastructure is the orchestrated version of that image. And the orchestration we'll do using Terraform. Who's heard of Terraform? Who uses Terraform? Hands up in production. A couple, yeah, nice. So my goal is to build disposable stacks, and Terraform is a tool that allows you to do that. And the cool thing about automating everything in an easy fashion is that test equals staging equals production. So you could build up your full production stack without any, well, there'll be a cost of course, but without any hassle, and then you can test if all of it works. And you can choose to either reproduce that as production or just promote that testing into production. You can do that. And one thing I like is the blue-green style, where you have your A deployment that is pointed to your floating IP, or you could replace the idea of a floating IP by a DNS service that does that for you. And then the second deployment is put ready, you could test it, and then you switch it, and deployment B becomes the active one, and you're all good. And Packer could do that for us in various ways. And here's a list of all the things that it supports. It's quite a bit. Pretty sure your provider or your setup will be in there as well. And if it's not, well, it will always be because you have custom, right? So eventually it will fit in. Normally, when people talk about all these tools that HashiCorp makes for us, there's always the Amazon angle. And Amazon is well supported, I can assure you that. There's lots of features, Amazon features in there. I'm more of an OpenStack guy, why? We have a brand that does AWS, but I'm not actively involved in a team. And most of our standard deployments happen in a managed way on VMware servers. But we've built an OpenStack platform when we want that more reproducibility, when we want that automation, when we want to have APIs that create all that stuff dynamically. And OpenStack is a bit more lightweight than VMware for that. And here's a script. Let's go over it. You have a builder. This is all just a JSON file. You have a builder. It's called OpenStack. You mention your endpoint. Here you mention your tenant, your username, and your password. I blanked that out, obviously. And then you could choose an image name. You could choose a fixed image name. That's the image name that will end up in your image repository. And what I did here is I mentioned the ISO time. This will not be the ISO time that will be outputted, but that's the format that it will use. So you'll have my build dash and then the timestamp. You can have multiple ones. You can name it the way you want. There's lots of variable interpolation possibilities. You choose a source image. That's the idea of my source image. In my case, that's a Debian Jessie. Could be a Debian Stretch. Could be anything you want it to be. Anything that is available in your platform of choice. Again, don't think about OpenStack. When you don't work with OpenStack, think about the technology you use. I'm pretty sure you could do it that way. Then you give it your SSH username, a domain name, a flavor, the network you want to attach it to, the floating IP pool that it has to choose an IP from. And then it starts. Then you do Packer, build, and then you mention that JSON file, and it starts doing its magic. Here's a schematic of how it works. You do the build, I talk to the API, it boots up an image, tears it down afterwards, does all the instrumentation, takes a VM snapshot, stores it in my image registry, and we're done. And when I do OpenStack image list, it's there, my build, among all the other stuff I have. And then again, we use Ansible to install stuff on it. And maybe I should dive a bit deeper on Ansible. As most of you know, it's a configuration management tool. I've compared it to competing tools like SaltStack, Puppet, Chef, Ansible. And Ansible is written in Python. It's pretty lightweight, more lightweight than its competitors. Maybe SaltStack is pretty lightweight as well. It's agentless, and that's what I like about it. It requires little setup. It's standalone, so you don't You don't necessarily need to have a big farm of configuration management servers. And what I also like is that because it's agentless, it needs a way to interact with the system, and it uses SSH for that. So as long as you have an SSH key and SSH connection, you're good to go. The units of work are called playbooks. Like you have all kinds of flavors, right? In Chef, it's a bit more cuisine-oriented, right? You have recipes and cookbooks, and in Puppet, it's modules. And it's called playbooks, and grouped playbooks are called roles in here. So you group them in roles, you install software, you basically can configure your server. These are some scripts to do so. So it's just a YAML file, and you mention what you want. You match hosts. In this case, I match all hosts, but you can match an individual host. You can match grouped hosts. You can define groups. I do sudo, which is a bit more like it's become user now. I think this is deprecated. And then you mention some tasks. This is not best practice oriented, right? This just gets the job done for me, because if you run it properly, you'll organize your files differently, but I'll show you in a minute. So the things I do is I use apt, I do an apt cache reload, and then I install vim, curl, nginx, php, fpm. This is just for fun and games, right? This is not actually production grade stuff. I create my var html folder, I give it some permissions, and on the next slide I load a template. That's also something you can do. This is Python based, so those will be Jinja or Yinya or whatever you call it. Kind of templates, you own them, you give them file permissions, yada yada yada. You copy an nginx file. You get the hang of it, right? We're installing PHP, we're installing nginx, we're linking the right configuration files. We've created a handler so that we can reload it all. And this is basically what it does. Now there are better ways to organize your playbooks, of course. There's far better ways of doing that. This is how you could do it. You have a files directory, you can store database files or other files in there. Then you have variables like host vars. Those are YAML files that contain variable configurations for individual hosts. You either name it default or the name of your host name, and then that will be bootstrapped. You have group vars, which contain variables for groups of servers. I will show you that in a minute. So you can have one for all servers, or you can have one for individual groups. You just define specific configurations there. You have an inventory, usually, that contains all the servers you have in your inventory that you want to orchestrate. In dynamic cloud environments, those will probably be dynamic inventory files. You could link it to a shell file and have some logic in there that dynamically figures out what the IP addresses are of your current stack, because your stack might differ. You have your playbook that will be loaded. You can also have multiple playbooks. And then you have the actual roles, and that is advisable. I didn't use it for this example because it was too small, but in real life you'll probably have a role for Nginx, a role for Apache, a role for MySQL, one for PHP, a common role that installs all kinds of stuff that you need. So you store them there, and a role contains default variables, handlers to reload stuff, meta information, the actual tasks, templates, and variables. That's the way it's organized, and these are more or less the best practices. If you want to run extra tasks beside your playbook that are not part of the roles, you can have tasks you include, and general purpose templates. That's a proper way of doing it. And then calling this could be this way. You can run a couple of tasks, have some post tasks, run a couple of handlers, load the roles, and this will just install nginx, Percona, PHP, fpm, without having to worry about how that is implemented. The only thing you do is you load it, you pass some variables to it, and you're done. So these are the regular stuff we run, and that's where we include all the rest. All of that happens in one of these files. And this is what our inventory could look like. You mentioned tags, and these tags could be groups. I kept it pretty generic. We have servers in the EU, we have servers in the US, we have web servers, we have database servers, and then you mention them all over there. And you can reference to them via group variables, via host variables, and so on and so forth. Right, let's continue. This is a template in Jinja format. It uses these Twig-style handlebars. You could inject variables in there, and those will be stored either in the roles templates directory or in your main templates directory. These are variables. This is just something I copied of something I had in there. PHP settings, database settings, Nginx settings, and that could either be stored as host variables or as group variables. So you're quite flexible. And if you run it standalone, you just run Ansible playbook, you mention the playbook, and everything will happen automatically, right? If something goes wrong, of course, which it won't. But in my case, we keep it pretty simple. We don't have to run it manually. There is a built-in provisioner for it. So I say type Ansible, I mention the playbook, and all of these runs and everything I showed you will be bootstrapped by Packer, and it will be included in the image. So we'll boot up that server, run or load it with the image you want, run all the Ansible scripts, take a snapshot, store it in your image registry, tear the server down, and then you have everything installed that you want. I've had a look at what it runs in the background, and when you run it via Packer, this is what it did for me. A whole lot of extra variables. But that's how it's done. So if we look at it in more of a schematized visual version, it will boot it will do the Ansible run, take the snapshot, store the image registry. We can add some stuff to it. We can even say, hey, after we run the Packer build, we want some meta information stored in the manifest JSON. And you can do that by specifying type as manifest and the output. And it will look a little bit like this. So there will be, this is an array of course, for every build that you do, it will be stored in the file. And then you have your artifact ID. So in this case, that's the ID of my image. And I could automate this. I could read from that file. I can do some processing using JSON processor, get that image ID out of there, and use that to automatically insert all that, to orchestrate that. And that image ID actually matches, if I do OpenStack image list, it actually matches that. And I have a video that I recorded because I don't want to do this live, because A, it'll go down. I didn't print the demo files this morning, so it will go down. And secondly, it will take too long. So I did a screen grab of it, put it in my Final Cut Pro, and sped it up times 4 or times 8 to make it less of a hassle. So let's see if that works. So Packer build, Packer JSON, it's loading everything. This is heavily sped up. Like normally this goes way slower. You see this is the Ansible stuff that is happening. Then it's stopping the server. Once it's done that, it takes an image, it tears down the server, and this is the output. The image was created with that, but it was also written to my manifest JSON file, so I could read that file, get that value out of it, and actually deploy the image. We could effectively deploy that image, but that requires some orchestration. And that's a bit of the tougher part. Like Packer, not that spectacular, right? You build something up, you have an image, it has all the stuff you need. But it gets interesting when you need to boot up the web servers. That's what orchestration is, right? Not just the web servers, but everything around it. The network, the load balancing, the floating IP, the SSH keys, all the things that surround it. And that you need to have a stable solution, but also a secure and a flexible solution. And that's where the problems start occurring. Every single platform has its own way of automating it. You have Azure that has Resource Manager, OpenStack uses Heat, CloudFormation is used by AWS, and these are all different syntaxes and have different capabilities, and that's where eventually Terraform comes into play. Terraform helps you to automate that without having to do specific implementations in the platform that your vendor does. You don't have to write CloudFormation templates. You don't have to use Azure Resource Manager. Terraform has its own syntax and is cloud agnostic. Just change some parameters and you can deploy to another cloud. I've been to the HashiCorp days in London, and one of their engineers did the deploy using Terraform to Google and Amazon at the same time, and put a load balancer in front of it and had it like a hybrid setup, and it was really cool. They really proved that you could be vendor agnostic and combine the two, have hybrid setups. So Terraform is an infrastructure as code kind of tool, and you can plan, graph, and execute orchestrations. Planning means it will do an estimation of what needs to happen, sort of a dry run, and it will present that to you, like this is what's about to happen, and then you know, okay, is this looking the way I want it to be? If it's too much information, you want a visual representation, you can graph it and it will create a graph for you, sort of hierarchy, and then you know all the bits and pieces in a visual way. And eventually you'll execute it, and you do that via terraform.tf files. Those have a certain syntax, you run those, and it works. It has multiple providers, and the cool thing is that it does incremental changes. So when you run it and you change something again, it won't tear it down entirely and reboot it up. It will look for the changes, do some advanced maths, and then figure out what needs to happen and only touch that resource. There's tons of providers, and I had to lower the font to make it happen. There's so many tools it supports, and I'm pretty sure that a lot of the stuff you use is in there. Like you could even do regular MySQL changes, New Relic, AWS is in it, RabbitMQ, you can do DNS changes. So you can have a pretty hybrid stack. You can use different kinds of vendors, because my OpenStack platform that I have is a limited one, so I don't have an S3 bucket style thing. We haven't deployed that yet, and we don't have DNS. We do have Power DNS, so I might want to hook that one up. So pretty decent stack using variable kind of tools. But again, in my world, I did the proof of concept with OpenStack, and I used the following terraform.tf file. It spans over multiple pages, so please bear with me. This is a variable, image ID, and I'll pass it to the Terraform binary. So you get the hang of it, right? We've created an image with Packer. That ID, I will inject it into that run, but if it's not injected, it will use that default value. Then I've specified a flavor ID. What is that? T1 medium. It was a medium flavor. I could extend that if I wanted to. I have a network that I link it to. I have a subnet that I link it to. And this is my public key that I assigned as well, because I need access in retrospect. Then I mentioned my provider. You can leave all of this empty if you want and use the typical environment variables. You can send environment variables to it and it will work. And then I specify a key pair, and I do it variably. This is this workspace thing. I'll explain later. Terraform can create multiple workspaces for you. And to make sure that these servers don't clash, I inject the workspace name in it, so my key will be by default key_default. If I create another workspace, it will have that name. In that way, you can have multiple stacks next to one another within the same platform. I give it my public key from the variable, and then we start actually doing stuff. I created a security group. It allows SSH access and it allows web access. I create an instance. It uses my network information. It uses security group, key pair, all the stuff I need, and it will boot that image up in that syntax. If you would use AWS, there's only a couple of changes you need to do. I have a secondary server, I have a load balancer, and that's where it gets a bit tricky for me. I have a load balancer, a floating IP that I'll link to that load balancer, a load balancer listener. I'm going to go over it quite quickly because this will hurt your eyes after a while. A listener is in a pool has a monitor to check if it's available, yada yada, all that kind of stuff needs to happen. You'll have two members in it, server 1, server 2, and once you have all that configured, you can run it. But before we do that, we have to run Terraform init. Because by default, all these providers, Amazon, Azure, DigitalOcean, they're not loaded. If you run Terraform init, it will lex your files and will see what kind of plugins it needs and then start downloading it. So in my case, when I did Terraform providers after doing Terraform init, it had the OpenStack provider ready. And then I want a sort of idea of what's going on, and I do a Terraform plan. And this is what happens. Again, a video for you. Plan, I inject my image ID, and I'm going up to show you all the things that it does. Some stuff is computed, some stuff is literal, and then you could validate yourself, is this what I want it to be? Is this good practice? But there's lots of information, and sometimes you just want a visual representation. If you do Terraform graph, you can pipe it to dot and then turn it into a PNG, and this is what it outputs. I know it's not ideal, but it's machine generated, and you can have, you see the hierarchy, right? It's better than nothing, agreed, right? It helps you figure out your stack. And when you're done, you run Terraform apply. I did create a video for it because it's very much the same video as planned, but I took the last output. So it creates everything, and you can generate outputs, and my output is the floating IP address. When I would go to that IP address, I would see my load balanced stack. It's just that simple. But there's better ways of organizing it, luckily. I have a couple of colleagues who are better at Terraform than I am, and they create several TF files. Within, when you do Terraform init, it will create a .terraform environment, and all the TF files are loaded. So you could split them up nicely. All your variables in there, the outputs there, security groups, key pair. You catch my drift, right? You could organize it and tear it up into reasonably small files. But what you can do as well is have, like what I did is server A, server B, server C. That tends to get tedious after a while. So you can define multiple resources in a single definition by using count. And then I can use a count variable And when I say I'm on 5 servers, it will boot up 5 servers. And it could use other interpolation syntax to inject a name, like my server 1, 2, 3, and so on and so forth. And then you have a variables file where all that stuff is defined. So in my case, like I'm deliberately going back and forth to give you an equal amount of attention, right? I'm doing things on this screen, doing things on that screen. So by default, we want 3 servers. We want it to be Debian Stretch, M1 Medium. They have a private network, so every node is not publicly accessible on the network, but eventually we'll figure out from the floating pool, we'll figure out a public IP and attach it to the load balancers. That's what we're doing right now. And all of that depends on local state. So state being stored in a Terraform.tf state file. But that's not ideal. Sometimes you want remote state, or you want a distributed state. And for that, we use yet another HashiCorp tool. They're very proficient in, like, I have to admit, the people at HashiCorp are excellent at figuring out what the problems are in the wonderful world of cloud and figure out the tool that solves it. And Console is one of these tools. Who uses Console in here? No, I'll check the other side. Console users? No. It's pretty similar. We use other technologies. Who use etcd? Who uses Kubernetes here? You run etcd probably behind the scenes. Zookeeper? You run Java, right? Zookeeper? Yeah. Sorry about that. Hey, I've always made fun, like the PHP scene always made fun of Java, right? You had these, I saw Johannes Schlüter, also a fellow German, had this t-shirt of a skeleton sitting by a computer with a spider web on it with the text, "Life's too short for Java." But by working, like I'm not a Java developer, but by setting up Java environments, I started to appreciate Java more. So I'm not a Java basher anymore. But Zookeeper, I had to set up a clustered Zookeeper, and that's how I got the hang of it. Console is pretty similar to it. It's a system. You could compare it a bit to Redis or Memcached. It's like a sort of store, a key value store over the network. And you can have a Terraform backend that you define in your Terraform file and link to a path and a host name of an individual console server or a cluster of console servers. And then you can do things like this. You can initialize your setup, and it will detect console, it will connect to console, it will check all the other stuff and download the providers. Then you can create workspaces, workspace 1, workspace 2, and you can select them. And then you can do a plan and apply. And you might have noticed in my Terraform files that I use Terraform.workspace as a variable that I interpolated in my names. Then you can boot those up. So when I do an apply here, it will create server1 underscore WSP1. When I switch to the other one, you'll have WSP2. And that's the basic idea. This is the output. I have default and new in my case. I made this morning, these examples. So they're sitting next to one another, and they're perfect copies of one another. And the cool thing about this, that this helps you with blue-green deployments. So what you do is you fire one stack off, it's in production, it's linked to your DNS record, and then you want to do a secondary deployment, but you don't want to bring that live immediately. You want to put it in a state where it has a public IP, where it's an exact copy of what's in production, but maybe with your new application code. And then you want to start testing it. You run the public IP, you have a look at it, and if it looks good, you can build a Terraform script, even a third workspace whose only task it is to switch the floating IP or to reset DNS. You could do that as well. I listed all the DNS interfaces that it has, but if you have a custom solution, you can write a custom provider, or you could effectively do an HTTP call to an automation script you've built. So there are ways to automate this in a very easy way. Afterwards, once you switch that IP, you switch back to your primary workspace and you destroy it. Because if you don't switch these environments, and I've tested this as well, so imagine you're doing a deploy and then you're doing a secondary deploy, and the only thing that changes is the image. Terraform will be intelligent enough to figure out that the load balancer needs to stay and all the security groups are intact, but those nodes change, and it will just destroy those nodes. So you'll be effectively offline. So that's why blue-green can matter. We're nearly at the end because we're starting to get hungry, right? This is a 40-minute slot, and we can do some QA if you want to, or we could leave for lunch earlier and skip the queue and make sure that the other guys in track 1 are still in their track, right? That's a plan. So there's way more features. If you look, I'm not specialized in AWS. I'm willing to become specialized eventually. But AWS, Azure, and Google Cloud have way more implementations because they have way more integrated services. You can create S3 buckets, you can probably do some Lambda stuff, you can generate changes in your Route 53 if you use their DNS service. There's way more solutions to automate this. And what I particularly like, and what I would advise you to do if you feel locked in and you feel that another platform has some features you might use, is create hybrid solutions. This, I agree, was a very 101 talk, but my idea was to give you those ideas so that you can have a look yourself. We agree, right, that the syntax of these Terraform files isn't that difficult, right? No? It's okay, right? It's not that bad. You can, it's JSON alike, we can use those. So that being said, I think I have 5 minutes left. I could do whatever you want in those 5 minutes. In the meanwhile, I would like to thank you for being here. My slides will be uploaded to my website. You can follow other presentations I have done or I will do. Follow me on Twitter. If you feel inclined, you can also follow me on Instagram. Okay. Thank you for being here. Danke. Ich bin hier auch für die Party heute Abend. Also können wir etwas trinken. Aber jetzt müssen wir essen.